The primary measure of central tendency for both weighted and trimmed data is the mean. However, other measures like the median and mode can also be calculated, but they may not be as informative. The median, for instance, is less affected by weighting and trimming since it only considers the middle value, and the mode might not even exist in trimmed data if the most frequent value is removed during trimming. In weighted data, we assign weights to data points to give more importance to certain data points. In this way, we provide a more accurate representation of the data when some data points are more important than others and reduces bias in situations where data is not evenly distributed. For instance, weighted averages are used in calculating grade point averages. Let's say a student takes the following courses with corresponding grades and credit hours. To calculate the weighted grade point average, first multiply each grade by its corresponding credit hours, then divide the sum of the products by the sum of the weights. Therefore, the student's weighted grade point average is 3.4. In trimmed data, we remove a certain percentage of the highest and lowest values from a dataset before calculating the average. This helps to reduce the influence of outliers or extreme values, producing a more robust estimate. Imagine a real estate analyst wants to determine the average house price in a neighborhood. They collect data on the prices of 10 houses recently sold in the area. The data contains two extreme outliers, houses 9 and 10, which are priced significantly higher than the others. To mitigate the influence of outliers, the analyst decides to use a 10% trimmed mean. This means removing the highest and lowest 10% of the data points before calculating the average. To do this, they first arrange the house prices in ascending order. Since they have 10 data points, 10% of this is 1. So, they remove one house from the top and one from the bottom of the list. Then, they calculate the average of the remaining 8 houses. This results in a 10% trimmed mean house price of $590,000, which provides a more representative measure of the typical house price in the neighborhood. The trimmed mean is calculated by removing a certain percentage of the smallest and largest values from a sorted dataset and then computing the average of the remaining values. Mathematically, the trimmed mean can be represented using the following formula. Where P is the trimming percentage, let X be the original dataset with n values, and K is the number of values trimmed from each end of the sorted dataset. If you'd like to test your knowledge on this topic, be sure to check the quiz link in the description below or visit our community page. Thanks for watching. Please like, comment, and subscribe for more statistics content.